Okay, so let's just look at a little code. First of all, the implementation of the consumer. So this is a controller. It's a regular Spring controller. Sorry, we're not using parts. And what it does is it basically gets a buy-sell request. It checks if there's available credit line, and if there's not, it makes a request for credit line increase, and it makes an actual call to a URL. Now, the way we're testing this is we built a tester for this, and we're using Spring MVC. So let's just see where the okay. So this is the consumer test. And the way the consumer test is it says it's stubbing those endpoints. So it's using Mockito to stub those endpoints. And it's saying if the REST template, if anybody calls a post for object, and it's asking and it's passing in the credit increase request class, that's the class that we're going to pass in to make our credit increase request, then it says return this. Okay, now this is the normal way that we're going to do this. We're going to mock the REST template because obviously in a CI/CD environment, you don't have a REST template that's going to actually work, and you don't want it to run against anything real. So we mock the REST template. This is where the problem lies. When you mock that REST template, if the REST template, if the actual the REST call that you're making changes, then you have to remember to change your stub, and that's not something that people are always prone to do. That's why these things break. So let's run this, and then we're going to make a breaking change. So actually, let's make the breaking change first. So on the on the producer side, that's a producer controller. Okay, the producer controller takes a credit increase request class. Now let's change that class because let's look at that class. Right now it takes the increase amount, the client ID, and the current credit line. We use that to decide whether we should increase the person's credit. Now let's say we have a little problem. There's a lot of hackers out there, so we want some additional information. So we want to add something to our request. So let's say we want to add a tax ID. I'm using Lombok here, so all of the getters and setters are generated automatically. I added a tax ID. So right now, I changed my contract, really, my API contract on the provider side. This test showed fail. Let's change our provider so that it compiles. So I'll add my provider changed the API, so they know what they're doing. They want to make sure their test passed. So they're going to supply all of that missing stuff. Okay, so now we changed our provider. Our provider test should pass. So let's double check that. We can actually run this test. Should work. Okay, we're good providers. We changed our API. We forgot to notify our consumers, though. So our consumers innocently still continue to try calling the old APIs. Those are going to fail. But let's see what happens with the consumer tests. The consumer test now, if it was test worth its salt, should fail. Doesn't fail. Didn't fail because, as we said before, we stubbed in the REST call. So this REST template thinks it's calling the old version of the API. It doesn't know that the API was changed. So this is where the contracts come into play. When you have contracts, you get rid of this stuff. let's get rid of the stub call, the Mockito stub. Let's get rid of this mock REST template. This is where we were doing our Mockito stubbing. And we'll replace it with a real REST template. Now what do you think is going to happen now? If I run this, there's nothing to make the REST call again, so it should fail. Okay, our test is going to fail because there's nothing to call. There's connection refused. Okay, so that's obviously not a good approach. So this is where the contract comes into play. So let's take a look at our contracts and see how this whole thing is going to work for us. Okay, with SpringContract, it works with a groovy URL, with a groovy DSL. So what you do is in your provider tests, or actually it doesn't have to be in your provider. We'll talk about different strategies, but the way that we are doing consumer-driven contracts is, since there could be many consumers consuming a service, you want to keep them in a common place. The best place to keep that for this type of workflow is in the provider side, because you have many different consumers. You have one provider providing for those consumers. So for each provider, you'll keep the contracts for that. You have to keep it under a directory called contracts, under resources. And you create a contract for each case that you want to test. So in one case, I want to test what happens if I have enough credit line. I want to make sure that it's going to return the right thing. So it says somebody's going to call a request credit increase URL. They're going to provide a body that on the consumer side is going to try to match any double. On the producer side, it's going to return a fixed value, or it's going to match against a fixed value. It also needs to have an increase amount, right? We saw in the call, in the postman call, it has to have an increase amount. And again, on the consumer side, that increase amount could be any double. On the producer side, we'll see how those tests work. The automatically generated test, that's going to be a canned value, 19,000. We'll use that in our testing. And we're going to put in a client ID of 1. And if we do all that, we're going to return a response that says take from the request body the client ID. So in this case, it will return 1 there. It'll give us the increase amount. So this is going to generate a stub that will generate that increase amount. There's no denial, so we'll put null for that. And we're going to return, on the consumer side, we'll return an arbitrary date. See how long I've been working on this. And then similarly, once you generate one contract, the rest are really easy to generate. We're also going to have a failed condition where we're asking for over $1 million credit line. We know that's going to fail. So now that we have those contracts, what do we do with them? So the way it works is the repository that contains the contracts, you call maven clean install -d skip tests. So it's just a regular Maven build. It will take those contracts, it's going to generate the stubs from them, and it's going to create a jar from those stubs, and insert that, it's going to install that jar into your binary repository. So for us, it's Nexus, it could be Nexus, Artifactory, it could even be Git. So we're going to skip those tests, and we'll run the install. Now look where we are, we're in the provider side. Remember, the provider side is where the contracts are held. And now let's see what generated. Just refresh. Okay, it generates in our target directory under my meta-inf mappings. It takes the provider name that I specified in my artifact, and it creates the stubs. So you look at these fancy stubs. Right? This looks nothing like my contract. Well, it resembles the contract, right? It has my current credit line, it substituted some regular expressions, it has my increase amount, my client ID, and it has my response. So this is a little bit terse, a little bit hard to read, but it's automatically generated for us. Thankfully, we never have to see that.
Is it Wiremark, right?
Sorry?
Wiremark.
WireMock, yeah. This is the WireMock stub. And it generates a stub for each one of my contracts. So both of these contracts are going to be generating a different set of stubs. And we can just see the difference.
You have to specify something in the Maven form file?
You do, we'll see now. Okay, so let's take a look at that. So there's different POM dependencies that you have to put into your consumer and your provider. Consumer side is really easy. You just put in Spring Cloud Contract Consumer. I'm sorry, no, that's that one. The Spring Cloud Starter Contract Stub Runner. What I normally do is just put in the dependencies. So the Spring Boot Bomb brings in all of the Spring Cloud dependencies. So I can just have a fixed version over there. And then I use the Spring Cloud Starter Contract Stub Runner. That's all you need. I'm sorry, you also need the Spring Cloud Contract Stub Runner. Why do I have that twice?
One's the starter.
One's the starter, yeah. I'm not sure if you need both of those. I don't know. Just be left over. But the consumer needs that to do the stub runner. So now let's see. We'll look at the stub runner in a second, but let's just look at the provider contract, the provider POM. Where's that? Okay, the provider POM is slightly more complicated. You need the Spring Cloud Starter Contract Verifier. You also need the dependency management for Spring Cloud dependencies. You need a Spring Boot Maven plugin that specifies, the Spring Cloud Contract Maven plugin that specifies a base test class that you're going to be using. We'll see how that looks in a second. So that's pretty much all you need on the provider side. Now you just have to, this is kind of cut and paste, you have to set extensions true so that it'll allow Maven to include any of the extra testing stuff and stub stuff into the build jars. Now let's take a look at this class. Now this class is going to be inherited. Remember we said that Spring Cloud Contract is going to automatically generate the test classes for the provider side. Those test classes need sometimes they need preparation. So in order to prepare, you create a base test class. It can be called anything. And then within the POM, you specify the name of the base test class. In this case, what we're going to do is create a provider controller, and we're going to pass it to rest assured so that when we inject our mock MVC into the tester, the tester will automatically require a mock MVC. It'll know to bring in this provider, this client provider controller. So now what we've done is we've generated our stubs. Now the tester on the client should fail now because now the client is going to be tied into this. Let's just finish off our client because we haven't done that yet. So the client test, there's a few extra pieces we did. Remember we changed it to a real REST template, but we got a connection failed exception. So what we need to do over here, and I have this in Git so it's all there, is all you have to do is say auto configure stub runner. That's the Spring Cloud Contract stub runner. You pass it in your Gav ID, your Gav coordinates. I put a plus here because plus means just get me the latest version, but you could use a specific version. You add the qualifier stubs because Spring Cloud Contract will take your Gav coordinate and it adds the words stub. And then you give it a port that you actually want this to run on. And even on your CI/CD server, this will be running under that port. Now, one thing I've done is, since I don't have Nexus here, you can specify it to run local. But you don't need to put that, and it'll deploy it to your binary repository. So now, all of a sudden, remember we were getting that connection refused exception from the REST template. Now we shouldn't get that exception anymore because the stub runner, the WireMock is going to install those stubs and it's going to actually mock those APIs. So let's run this now. this still pass? Why did this still pass? Did I change the contracts? Got to change the contracts. Yeah, so in order to be a good provider, I have to make sure and I change the contracts, otherwise the provider test would fail. If I just ran the provider test just now, that would have failed, because I didn't change the contracts. So everything is guaranteed to be in sync. Now, I'll go back to my terminal. Remember how we generate the stubs. We have to call maven clean install minus d skip steps on the provider side, the place where the contracts are being held. And now if I run my client, my consumer test, that should fail because it no longer conforms to that contract. And we see, they give you really good logging information. They show you the closest stub was request credit increase, and they show you what the problem was. I'm missing the tax ID. So it tells you exactly what the problem was. Okay, so how do we fix that? So let's get to work on fixing that test. So what we could do is on the consumer side, we have to modify our credit increase request so that it includes the tax ID. We have to modify our test so that it includes the new API. Why does it seem like that? Okay, so we added the client tax ID over here. And everything else is set up. So now this should work. I haven't changed the stub, so I don't need to regenerate that. Let me run everything from Maven and just make sure everything is working. So we'll go into Maven. On the consumer side, the test should now pass. I'll do Maven clean install. Hopefully I changed all of the stubs. We get a green build on the consumer side, and on the provider side, again, we're running against the same set of contracts, so I don't have to skip tests anymore, because now I really want to run the provider with the provider automatically generated tests. So I can do a Maven clean install on the provider side, and now those tests should pass as well. So that guarantees us that the client and the producer are both conforming to the same set of contracts. So it's really nirvana. Now all of a sudden you have all of these microservices, and you have now tested that missing link that you have your, and we see it turn screen, that you have consistency between what your provider is promising in the contract and what your consumer is expecting to consume. Just let's talk a little bit more about the consumer-driven contracts workflow. So it's really like TDD, right? In TDD, what do? With test-driven development, we create a test that fails. We build an implementation that makes the test pass. That's what we do in consumer-driven contracts, but we do it in a unified way, in a coordinated way. So we're coordinating a provider and a consumer to do test-driven development together. So the contracts are shared by consumers and providers. The consumer writes a failing test that exercises the call to the provider. They make that test fail as we did. The consumer will now, they have to have a place to make the consumer changes. It's consumer-driven contracts. So the consumer makes a copy of the provider project or wherever the contracts are, and it makes the changes inside of the provider contract to conform to the changes that the consumer is trying to drive. It generates the stubs. It makes the consumer side pass, the test pass based on the new stubs, and then it creates a pull request to share the contracts with the provider. It's coordinated, so you have to be talking to the provider and saying, okay, we're going to coordinate this. The beauty of this is when you're not changing your APIs, the consumers and the providers are both running against the same GAV stub version, So everybody is always working. If somebody accidentally changes something, even though their own local tests are working, the contract test will fail on either the consumer or the provider side. So now the provider gets these new, they did the pull request, they get the contracts, they see that the test is now broken. They have to provide the functionality that will fix that test. They do that. They make the test pass by passing the new, by implementing the new functionality. So by having the shared contracts, we guarantee that the provider and the consumer are never going to be out of sync. It gives us immediate, current, accurate feedback without having to set up any new infrastructure. Now, what Spring Cloud Contract adds, it's a Groovy-based DSL for defining shared contracts. It's really easy to use. Even if you don't know Groovy, it's just a simple DSL. We saw examples of that. On the consumer side, it automatically just generates those stubs, and it automatically kicks off WireMark. The stub runner plugin really is just it's a wrapper around WireMark. And on the provider side, it automatically generates these tests. We didn't look at those tests, so I'm going to look at them right now. But just quickly, so this is the contract that this is the sample contract. Now let's look at the stub that it's generating and compare them. So you see that the stub has a post method with request credit increase. The contract has that. It has this ostensibly regex matchers. And then on the bottom, it does the same thing. It's matching the same URL. It's changing it into a stub. It's a post stub. It's taking our headers. It's taking our body matchers, right, the regex that and it's returning the values that we set. On the server side, this is what the generated tests look like. So it's a REST easy thing. It uses given, when, then, and it supplies all of the data that was taken out of the contract. So you say it pulls the content type, it pulls the regex, everything that it needs to send in the data to the test. So on the provider side, we want to use hard-coded data. That's the hard-coded data that was in the producer method in the contract. And then on the server side, we want to verify that something works. So those could be regexes. So it's exactly the opposite of what we had on the consumer side. On the consumer side, on the request, we had regexes. On the response, we had hard-coded values. On the provider side, we do the opposite. On the request side, we want hard-coded values. And then on the response side, since we're using those values to test if something conforms to a kind of value, we use a regex. It's a little hard to get your arms around them. That's basically what you do over and over again. The tests are automated, so they run on your CI/CD server. They're always guaranteed to be in sync, as we said, so every time the client does a build, if the contract changed, they'll fail. Every time the server does a build, it'll fail also. That's one model. So that we've been talking about consumer-driven contracts. These are great for working in an enterprise. I work at a bank, and it's we are coordinating our development with across all of our microservice teams. But it's also possible that you have an API provider that's external, like you're just providing an API, and you want to make sure that all of the people that are calling your API understand what you're providing. So in that case, you would use not consumer-driven contracts, but provider-driven contracts. And in that case, the provider themselves would be responsible for making the changes. Just a slightly different model. Okay, so that's pretty much it. These are really great links. This is a step-by-step guide to consumer-driven contracts by Marcin Graychak. He's pretty much the main committer on this, and he's written a really good guide. If you had looked at this in prior generations, the guide was not very good, but like a week ago or 2 weeks ago, they generated a really excellent guide. You can print out PDFs. He gives you all of the possible cases, where to store contracts, different methodologies, and stuff like that. As I said, there's also a framework called Pact. Pact integrates with Spring Cloud Contract. but it also works very good. It's another top, if you're interested in contracts, you may also want to be looking into PAC if you have multiple polyglot applications. And that's pretty much it. Yeah.
Question, I mean, when the provider generates that stub, does this get directly pushed down to the Nexus repo?
Yes.
So that is the most
When the
important.
consumer does the stub, normally so if you're doing consumer-driven development, the stub that the consumer produces might not get, you don't have to send it to Nexus. You can say work locally.
No, I mean, all the services that I consume is all remote services. So,
Right, so if it's all remote services, you wanna coordinate with somebody, you wanna make
yeah,
sure to push.
so we have a conference page, look for the contract change, and we work on that, which is kind of disintegrated. So, you know, that's for all I know, like when it goes into the, integration testing, that's when we figured out the contract was changed. So this
Yeah,
thing.
so this is something that.
Yeah, this is what something like really good.
Yeah, we get burned by it all the time. What we've been trying to do before we started looking into this in our company is we just always try to make sure everything is backwards compatible. We were getting burned a lot, so we realized we had to do something.
Can you talk about how you version them?
How do you version the contracts?
Yeah.
So I purposely glossed over that, but you can include the version in the URL, so you can have V1, V2 like that. And so you can still be promising the old version of the contract and be working on two contracts simultaneously, multiple contracts simultaneously. As soon as you put that V1 in the URL, it'll only match people that are calling V1. If you put V2
But
in
you have
the
to do it via URL. You can't keep the URL the same.
if you do, then you want to make sure that you're coordinating with the consumers, so that everybody's making the change at the same time. That's exactly what you need.
But in the enterprise environment, we have multiple environments. For example, a dev, QA, UAT, and production. And sometimes we want to keep the same URL, but the underlying contract might be changing between the environment. And especially in a multi-team environment, we got burned a lot.
It's still a regular release process, right? You have to make sure that you're releasing what you tested and what you developed.
But the contract, but the one we in the demo that you did, that we need to find out the specific main modules to get that user that stuff, right? With that, if we have different environment and we cannot go get to the same.
So then there's also, as far as versioning goes, as far as versioning the stubs, you can also specify that in the Gath coordinate, you're specifying the version of your stubs. So it's whatever POM version that you had. I had a plus sign in there,
Oh,
if
yes,
you remember.
yes.
You can specify specific versions there.
That means that.
So the plus gets the current version.
Plus gets the latest version. Thanks, everyone.